Today, we want to talk about an embedded lab project that has finally found commercial use. This project is a remote monitoring and control system. Especially, we will focus on building a system to monitor and control the environmental conditions in a chicken farm. Awareness and control of the environmental conditions in a chicken farm is vital for owners of this job. Over a 45-day period, the chickens must reach the required weights for sale. Because of the costs are so close to the profit in this job, it is critical to carefully control the environmental conditions in order to create maximum productivity. Since many types of sensors and microcontrollers have been introduced to the market at reasonable price in recent years, there are good opportunities to introduce low-cost solutions to various challenges. But on the issue of the chicken farm, we could not use any tools or methods to monitor and control environmental conditions. Issues such as dust and shock had to be considered. We could only use a Wi-Fi connection to transfer data over the web, needed an online and real-time connection. We were asked for a desktop software for monitoring and control. To do this, we needed a series of equipments. Some were software like Arduino IDE, Firebase, and Visual Studio. Some were hardware such as sensors, actuators, microcontrollers, and peripherals. Here we see the necessary hardware, which includes a temperature and humidity sensor, an LED in a role of actuator, and a microcontroller, which is also responsible for Wi-Fi communication. The codes were transferred to the microcontroller via Arduino with the help of USB connection. The Firebase platform provides a real-time database and a desktop user interface software for monitoring and control. Next, Ms. Golshan explained the hardware and the Arduino codes. Then Ms. Asadi will explain about the database and software. Thanks.
Our effort was based on the use of the simplest hardware architecture. We used a Node MCU microcontroller type, and there was a thought behind choosing that. First, it has low cost, and second, this microcontroller has been implemented with Wi-Fi module inside by default. When it comes to sensors, a temperature and a humidity sensor will be used in this project. We chose DHT11 modules for our humidity sensor because of its stability and low cost. About peripherals, a breadboard and a jumper wire will be utilized. Now let's see how it's done. In the first step, through Arduino IDE, we did some initial board setting and imported required libraries. Next, we defined some variables such as humidity and temperature, time, and so on. Moreover, some libraries were needed, Wi-Fi connection and online database libraries, for instance. The input and output pins will be specified for sensors and actuator, and then we applied the essential codes for connecting to the router and also Firebase in a way that data can be read and written at the same time. Finally, we wrote some codes to process exceptions like database connection problem. That's all I had time for. Let's turn to Sarah.
Our next step is to create a real-time database. First, we create an account and make a project. It gives us a link that we can use in Arduino to connect to our database. After that, we create a database and define some attributes to connect them to our variables. It provides a secret code that we put in our Arduino code. We create a user-friendly UI based on our customers' requirements. In this project, we receive data from the Firebase real-time database, and we can see the results on the graph immediately. Also, we can turn our LED, which can play the role of our actuator on and off, and it provides an Excel output of our results. In our future work, we are going to add relays to control fans and lamps, and add a monitor so workers can check the environmental conditions. Also, we want to add a protection shield to our module and a buzzer to alarm us. Based on our new features added to the project, our user interface needed to be modified. Also, we can build an Android application for it.